Okay, so in our last video, we looked at this idea of heat transfer from like a hot object to a cold object, which is pretty intuitive to us because we've experienced this all the time, right? You go and you pick up a warm cup of coffee or tea, you put it on your hands on it, it feels warm because the heat's transferred from that hot object, the coffee, to your hands. So you feel that heat transfer. Now we're going to talk about something that's a little bit less intuitive, is this idea of a reaction, and a reaction releasing heat or gaining heat, and why it would do that. So let's look at a couple of examples. The first one, right, we have methane, which is just simply natural gas. And maybe we go and we turn our stove on, okay? And it's going to produce carbon dioxide and water, okay? So we go ahead and we let this reaction happen. Now, from experience, we know that this reaction gets warm, produces heat. So we can go ahead and say, well, we're going to produce heat over here. So it's going to release heat. Now, this isn't something where it's like, oh, our methane is hot and it transfers heat to our products, which get warmer, right? It's not this transfer of heat idea that's directly from like a warm object to a cold object. There has to be this heat coming from somewhere, okay? Now let's go ahead and look at another example. Another example would be if we take ammonium nitrate, okay, and we go ahead and we dissolve it, so we just put it in water, we would see that we would dissolve it, we'd say, okay, now it is aqueous, so all we've done is change the physical state from solid to aqueous. Now if we did this and we felt the beaker that it happened in, it would actually feel cold, okay, so we can go ahead and say, well, it must be absorbing heat, which is why it feels cold, okay. Well, we have these two types of reactions. We notice one has heat as a reactant, one has heat as a product. We have two ways of identifying this. The first one, this is called an exothermic reaction. So it produces heat, okay? So we can say here, it has a loss of heat. So it gives it away, therefore it's a product. This one is an endothermic reaction. So it's endothermic, it's absorbing heat, okay, or we can also think it gains heat. Okay, so we have these two types of reactions. Now we've kind of had the idea of being able to experience something like this. We turn the stove on, it gets hot, you turn your barbecue on, it gets warm. It's an exothermic reaction. Endothermic reaction, you dissolve something or you undergo a process where it absorbs heat. Now let's go ahead and talk about why. It's not this idea of something's hot and it's transferring heat to something that's cold, okay? So we're going to use this idea of an exothermic reaction. So let's go ahead and say we have hydrogen and we are going to react it with oxygen. Now when it does that, they're going to react together and give us water. Okay? So now when we let this reaction happen, similar to this reaction, we are going to produce heat. So we have to think, where is this energy coming from? And we got to remember, what is heat? Remember, heat is transfer of kinetic energy. So we must be getting energy change here, right? When we go back to the beginning, when we first talked about energy, we said energy can kind of be broken up into two broad categories. Potential energy and kinetic energy, right? Energy of motion, stored energy. When we go back and we think, in this reaction, where would the energy be stored? Well, the energy here would be stored in our bonds. So we see we have a reaction happening. We are breaking this hydrogen-hydrogen bond. We're breaking this oxygen-oxygen bond. And what we're doing is we're forming hydrogen-oxygen bonds. Well, when this is happening, we are changing potential energy to kinetic energy. Okay? So for an exothermic reaction, what we notice is that some of the potential energy is converted to kinetic energy. So what does that do? We are getting kinetic energy here. It's going to increase the average kinetic energy, which we would notice increases the temperature, right? So that's why exothermic reactions feel warm. We let our potential energy convert into the kinetic energy. That increases our average kinetic energy. It's a higher temperature and it feels warm. Well, the inverse is true for an endothermic reaction, right? We're going to get kinetic energy right? Because in this reaction, we have kinetic energy. The molecules are always moving. And it's going to convert to potential energy, which means we decrease the amount of kinetic energy, which decreases our average kinetic energy, which decreases the temperature. And we're just ending up with more potential energy. Okay? So it's this idea of converting between stored energy and movement energy that causes us to have an exothermic reaction or an endothermic reaction based upon the bonds that are broken and formed. Okay? So that's why we get exothermic and endothermic reactions. It has to do with the bonds breaking and the bonds forming and the relative strengths of these two. Now in class, we're going to discuss how do we look at the relative strengths of these two and then predict it's exothermic or endothermic or vice versa. Exothermic and endothermic, how does that tell us, or what does that tell us about the strength of bonds that we have in our reactions? So I hope to see you then.